Above ground stems are the main support for things like leaves and flowers and fruits for terrestrial plants. Some stems, as it says in your notes, are even capable of photosynthesizing, as are the leaves. So let's take a closer look at stem morphology, and we'll also take a look at the various types of stems. Our typical stem cross-section of a plant would look something like this. This is a cross-section of the stem of a plant called medicago, which is more commonly referred to as alfalfa. And we can see the various types of cells. We've got different sizes of cells, different shapes of cells here. So let's start from the outside and work our way in. And the outermost layer here is referred to as the epidermis. The epidermis is, again, the outermost layer of cells, and its function is to protect the stem from damage and desiccation. Desiccation just means drying out. It does this by secreting a wax layer, typically on the outside of the stem, and in plants that are referred to as woody plants, over time the epidermal cells will continue to build up and will form a layer of what we refer to as bark. The region just inside the epidermis is referred to as the cortex, and it can include the xylem and phloem, which we refer to as the vascular tissue. Now, the way in which a stem's vascular tissues are arranged can tell us a few interesting things about this plant. Number one, it can tell us, in a broad sense, which type of plant we're dealing with here. Plants can be divided into groups based on the number of so-called seed leaves that they have. Plants develop these seed leaves within the seed, and they're the very first leaves to emerge from the soil when the seed germinates. If the plant has two seed leaves, we call it a dicot. It's important to note that, again, that this is two seed leaves. The plant will certainly down the road have more than two leaves. Or we can find that the plant only has one, in which case we call it a monocot, which means it has one seed leaf. In dicots, if we look at their cross section, we'll see that the vascular bundles, and this would be one vascular bundle right here, we'll see in this case, as I'm putting a dotted line here, that the vascular bundles are arranged in rings. For dicots, the vascular bundles are in rings. In dicots that live for more than one growing season, we will see a layering of vascular bundles, and they're going to form the so-called rings that we see in woody plants. Monocot stems, when in cross-section, have a more random distribution of vascular bundles. So we'll say the vascular bundles are spread throughout the stem. Let's look at a photo of a monocot stem in cross-section. This is the cross-section of the stem of a corn plant. We can see we have an epidermal layer here in the outer portions. But in addition, we have vascular bundles that are not arranged in a ring pattern. These outermost ones might appear to be in a ring, but when we look towards the middle portions of the stem, we'll see that they are more randomly arranged. And so if we wanted to depict this quickly without the use of a photograph, which you might want to do in terms of answering a question on a quiz or an exam, you would draw it, and you could say the monocot's vascular bundles would be arranged more randomly, while the dicot would have vascular bundles arranged in clear rings. Some students have told me that the way they like to remember it is the monocot cross-section looks like a pepperoni pizza. Now, we'll get into some more details and some more differences between monocots and dicots. You can also readily tell a monocot from a dicot based on the type of leaves that it has, which we'll discuss more in the next module when we get to leaf morphology. So moving forward here, we talked about the vascular bundles, in which case we have one right here. So let's label that. The vascular bundle, again, includes the xylem and the phloem. And the remainder are various types of thin-walled, generic type cells that we would collectively refer to as parenchyma cells. In certain plants, they'll refer to this even as the pith, P-I-T-H, for example. But they're basically there for structural purpose or to, in a lot of cases, store water, and don't really have much of a function other than that. In a prior module, we talked about the way in which stems lay down their meristems, and they put them at the tip and also have behind the tip what are referred to as the subapical meristems. But in plants that grow, particularly dicots that grow for more than one growing season, there are additional meristems as well to be found in these stems. And so let's take a look at one of those plants. This is a cross-section of a stem from a basswood tree. And let's label this so we can tell what it is we're looking at here. Now, basswood is a dicot, and it is a woody plant, and it is what we refer to as a perennial that lives for more than just a couple of growing seasons. And being that it's going to grow into a tree form, it has to be able to increase the girth of its trunk and the girth of its stems so that it can support all of those leaves and branches that are going to grow beyond this point. And so to do so, it needs to grow outwards. Here is the central portion of the stem. On the outer edge here, we would not refer to this as epidermis per se, but we would refer to this as bark. What the bark is basically a bunch of dead cells that have been compressed and crushed as these cells inside of them continue to multiply and grow. And these cells build up in layers, and we refer to those layers of dead cells as cork or as bark. Immediately inside of the bark is where we see the living tissues, and this region right here that I'm circling would be the phloem, and this region here is the xylem. Every year this tree is going to grow, and as it grows it needs to increase its diameter of this stem, and that growth comes from cell division going on right in this region here. Let me use some red here. To sort of trace this thin region between the xylem and the phloem. And that is what we refer to as a lateral meristem, and in this case we call it a cambium layer. So the cells divide and grow in the case of phloem to the outer portion of the stem, and in the case of xylem they grow towards the inside. And as these xylem continue to grow and expand, the stem increases in diameter. And these phloem cells, from year to year, they keep producing new phloem cells, but these phloem cells are destined to become crushed and part of the bark layer. The xylem cells remain even after they're no longer functional, and when this occurs over a number of years, we get multiple layers of xylem within the stem. And so this is this xylem that I have labeled here. Let me maybe switch to yellow and go over that so we can see it a little bit better. This xylem in this region right here is the current year's xylem. Inside of it, this inner ring here is last year's xylem. And inside of it is yet another year's worth of xylem. And so we could say this is the first year xylem of this particular stem. This is the second year's xylem. And this is the current year's xylem. So this particular plant here we're looking at is 3 years old. And this division, and mostly what we see is a difference in density and size of cells because of differences in seasonal growth patterns. We see rings, and this is the so-called rings of a tree. Each year it puts down a new layer of xylem, which forms a ring. To this point, we've only discussed above ground stems, whose, again, purpose mainly is to support leaves and possibly flowers and fruits down the road. But there are a number of modified type stems that certain plants find useful to help them survive. And there are a number of them that you need to be familiar with. The first is called a rhizome. Now, the root word behind this word actually means root or root-like, R-H-I-Z. Well, we're referring to stems here, not roots. Why do we call it a rhizome? Why even use that? Well, because of where it's found. A rhizome grows underground. It grows horizontally. And a great number of plants grow these types of underground stems. Many of our turf grasses rely primarily on rhizomes for spreading and colonizing new ground. This is a photo of some Bahia grass rhizomes, and the rhizome is actually this region right here. You can see there are roots growing from it. But what makes this different from a root is you can see, if you look closely here, these dark lines across the rhizome here. Those are nodes, and at each of those nodes you will find meristems that are capable of growing stems with leaves on them like this. You don't see segments like that on the roots, and so technically that's what separates this from a root, the fact that it has subapical meristems. And roots, as we've already discussed, they don't branch in the same way as stems. So technically speaking, this rhizome is a stem. It is not a root, even though it normally grows underground. In the case of Bahia grass, not only does this allow it to spread, but these rhizomes are very thick and fleshy, and they help the Bahia grass conserve moisture and store moisture. And this is one of the things that makes Bahia grass one of the most drought-resistant turf grasses that we can grow in the southeast. In addition to rhizomes, there is another horizontal stem that we refer to as a stolon, or stolons plural. And a great number of turf grasses also grow stolons, and they basically work the same way as rhizomes, except they grow above ground. So they are above ground. They grow typically just on the surface of the ground. So they are above ground, horizontal stems. And here are many Bermuda grass stolons growing across some bare concrete in search of new territory to basically colonize. While rhizomes and stolons are mainly used to, like I just said, colonize new territory, there are several modified stems that are used primarily as storage organs. And the first of those are referred to as tubers, and these are probably the most familiar to you. And many of you are probably already thinking of the example that I'm going to use for a tuber. And a tuber is an underground stem, and they are typically very fleshy, and we'll also say starchy. Starch is a type of carbohydrate that is less soluble than sugars and is very helpful for plants to store energy in a chemical form for the long term. And so let's take a look at an actual tuber, and as most of you have guessed, it's going to be this. A potato is a tuber. Your red potatoes, your Idaho type potatoes are truly tubers, whereas your sweet potatoes are actually modified roots that are used to store carbohydrates. And what lets you tell the difference between the two is the fact that true tubers will have eyes, and eyes, if you keep them in the dark long enough, they will sprout and form actual stems. What they are is basically subapical meristems waiting to break, and you can see that this one has begun to sprout. And so technically it is a stem, not a root. In addition to tubers, we also have another type of storage stem called a corm. And corms also grow underground, as it says in your notes. If you look at a corm, it looks basically like a rhizome or a stolon, except that it is very, very densely compressed. So we'll say a highly compressed stem. And let's take a look at one. This is a corm, and you can see on this end we have the roots coming out of the bottom of the corm, and on this top portion here there was a stem that was emerging from the ground that's been cut off. Now, what makes this different from a tuber? Well, if you look closely, like I said, this is like we took a rhizome that would have been stretched out like this with its nodes on it, and we compressed it from both ends. And if you look closely here, you can see right in here is a ridge, and this is a ridge, and these little buds are all growing from these ridges, and the ridges themselves are the nodes. And so you can see multiple nodes here, whereas on a tuber you don't see those nodes. You just see the eyes distributed all around the outer surface. And so that's the difference between a tuber and a corm. The corm has these nodes on the outer portions of it, and a tuber does not. The final type of modified stem that we'll talk about is called a bulb, which should also be somewhat familiar to you. A lot of different crops are grown, both ornamentals and vegetable crops, from bulbs. A bulb grows underground, like tubers and corms, and it has the basic structure of an above-ground stem, except that it's highly compressed, and unlike a corm, it has leaves. So we'll say a highly compressed stem with leaves. And our good example of this would be an onion. You can see this onion has been sliced, and this is the end from which the roots would have been growing. And it may be a little difficult to see in this photo, but basically what we've got is right in here is an apical meristem. And then there is a leaf around it, and there's another leaf wrapped around it from this point. And then inside that will be another meristem with a leaf wrapped around it. And as you can guess, I could keep drawing all of these layers, at the base of which you would find, I'll just do it for one side here, at the base of each of these leaves you would find an additional meristem. And so it basically is one of these that's been highly compressed. This is again our coleus stem cross section from a few modules ago with our apical meristem and subapical meristems, and this is an above ground stem. But if we took these leaves and compressed them tightly around that, and took these leaves here and compressed them, and this leaf likewise here, followed by an additional subapical meristem with its corresponding leaf layers, we start to get the looks of a bulb like this onion.